In this video, we're going to talk about what happens when your gas variables are not being changed. Is there an equation that lets us just, figure out if we have three of the four variables, pressure, temperature, volume, and amount of gas? Is there a way that we can, given three of the four, calculate the fourth one? And there is, and that is our ideal gas law. Okay, so our first ideal gas law problem comes up on slide number 23. And you'll recall that our ideal gas law is that PV, pressure times volume, is equal to N, the amount of gas, R, the universal gas constant, which you will need to memorize, T. Okay, or for short, to help you remember it, we say PVNRT. Okay, PV equals nRT. So on slide 23, our question reads, assuming ideal gas behavior, how many moles of helium gas are in a sample that has a volume of 8.12 liters at a temperature of 0 degrees Celsius and a pressure of 1.2 atm? Okay, so if you take AP Chemistry, we'll talk about variations or deviations, I should say, from ideal gas behavior. But for now, we're just going to assume all of our gases behave ideally. And so we're going to assume that we can apply the ideal gas law to all of our gases. Okay, so our volume is 8.12 liters. Okay, our temperature is 0 degrees Celsius. Again, it's a gas law problem. You best be converting to Kelvin. So we're at 273 Kelvin. Our pressure is 1.2 atmospheres. And you will remember, or you should remember, okay, that our universal gas constant is 0.0821. And our units for that constant are liters, ATMs, per mole Kelvin. Okay, and when you see this unit plugged into the formula, you'll understand why it's a little bit crazy. Okay, R needs to have those units just to get everything to cancel appropriately when you're solving these problems. Okay, and again, the question wants to know how many moles of helium gas. Okay, so what's N? What's our moles of gas? So if we plug everything in, we get PV equals N R T. Okay, this is pretty easy algebra. We need to isolate this variable. Okay, so you'll get that N is equal to 1.20 atmospheres times 8.12 liters divided by R, 0.0821 liter ATM per mole Kelvin times 273 Kelvin. Okay, and when you crunch these numbers, you get that the amount of gas present is 0.435 moles of helium gas. Okay, so these are pretty straightforward. The biggest things to remember here, right? Nothing's changing, and you do need to memorize this universal gas constant of R. Okay, so now we're going to try the problem on slide number 24. A little bit more tricky because we start talking about molar mass, but don't worry, y'all already know how to do this. The question on slide 24 reads, a sample of aluminum chloride weighing 0.1 grams was vaporized at 350 degrees Celsius and 2 atmospheres of pressure to produce 19.2 milliliters of vapor. Calculate the molar mass of aluminum chloride. What the heck? Okay, don't worry. Let's take it one step at a time, assemble what we know, assemble what we don't know, and figure out how are we going to get from PVNRT to molar mass. Okay, so recall the ideal gas law, PV equals N RT. Okay, this problem gives us that the mass of the sample is 0.100 grams. Okay, gives us our temperature is 350 degrees Celsius, aka 623 Kelvin. Okay, our pressure is 2 atmospheres. Our volume is 19.2 milliliters. Okay, but you know it needs to be in liters, so we need to be converting. 1 liter contains 1,000 milliliters, so our volume is 0.0192 liters. Okay, R, we know that already, and we are asked to find N. I'm saving myself a little bit of room. Green Club, don't want to use extra paper. Okay. So if we plug this in, we get PV equals N R T. Okay, if we're isolating our moles of gas, okay, we're going to get 2 atmospheres, 0.0192 liters over R. And temperature. Okay, if you plug this in, you can figure out that we've got 7.51 times 10 to the negative 4th moles of this gas. Okay, or I'm sorry, moles of aluminum chloride, which has been vaporized, right? You know, aluminum chloride is a solid that's soluble. I think it's soluble in water. Okay, it's got to be pretty hot to get that to vaporize. Okay, but you would, if you vaporized it, you would have 7.51 moles. Okay, the question wants molar mass. Well, what does molar mass mean? We know that molar mass, by definition, is the mass of 1 mole of a substance, right? Or it's the number of grams per mole of that substance. Well, we have grams, we have moles. Set it up. Mass, or grams per mole. And we get roughly 133.2 grams per mole, which is pretty dang close, okay? I think if you look it up, it's like 133.6 or something, okay? So the hardest part of this problem, I think, was this step right here of remembering what is molar mass, what does it mean? Okay, remember it's grams in 1 mole of that substance. Okay, so that's ideal gas law. Next, we're going to talk about what if you've got more than 1 gas present, okay? Because, of course, it can always get more complicated in chemistry, okay? But don't worry, it's not too bad. We'll take a look at Dalton's law of partial pressures coming up next. Stay tuned.